Greater the distance from the pivot, greater is the moment turning effect. I had explained that moment is the main topic of this chapter, and as I was saying that in every chapter there are some of them, some topics are their favorite. So starting from the syllabus first chapter till the end, if you remember their favorite topics and you get a good grip on it, what's the meaning of good grip? I was explaining this to my students today also in the class, that the grip means what they want, you have to write that. And I have shared some documents, and same thing. So people were asking that how we can improve the answer quality. So the best thing is the examiner report. Above that, student response booklet. A little work on that will improve the grade a lot, because many people write right answers but not what they want. This is where the problem occurs, and obviously examiners do not have that much space because of the marking scheme constriction. So remember that when you find a topic like turning effect, for example, they like that topic. So when you are doing past paper theory questions, so always try to look at the examiner reports. Examiner reports are very helpful. So greater the distance from the pivot, greater is the moment. You have to copy this screen. I'm just coming, copy this screen. For example, screwdriver and the jack. This is an instrument used to lift the car when the car tire gets punctured. Long force arm of a crane. This is a long force arm of a crane. So these are the instruments and these are the long arms, which shows that greater the arm, greater is the moment.
The same force may produce different effects depending on the point of its application. Each time, the acting force causes movement of the book. However, as we can see, the rotation of the book depends on the point of application of the acting force. What does the ability of a force to rotate a body depend on? It is much harder to close a heavy door when we push it near to the hinges than when we push it close to the handle. The ability of a force to rotate the door depends on the distances between the line along which the force is acting and the axis of rotation. The greater the distance, the easier it is to rotate a body. The distance between the line along which the force is acting and the axis of rotation is called a force arm. The same force may produce different effects.
At first glance, it is not easy to say who will undo the nut with smaller effort. It is obvious that the ability of a force to turn a body is determined by the length of the arm, as well as the magnitude of the force. In order to compare the abilities of two forces, we need to take into consideration both the force arm as well as its magnitude. The product of the magnitude of a force and the force arm is called the moment of the force. The unit of moment is Newton meter. The moment of the force in the picture is 20 Newton meters. At first glance, it is not easy to say who will undo.
Using a spanner of a suitable length, we may undo a nut of a wheel quite effortlessly. However, pressing slightly harder, we may suddenly break the nut. The moment of a force is a quantity that is often stated by manufacturers of various devices. It determines the threshold magnitude of the moment of the force that can be applied while tightening a nut. A special spanner makes it possible to set a required value of the moment of a force. The spanner tightens the nuts without exceeding the set value, and then switches off automatically. Using a spanner of a suitable
Principle of moments. This is a very important topic. Now give the heading.
Done.
Principle of moment. It's a very important topic and it comes very oftenly. This principle is applied when a pivoted object is in equilibrium, or simple words, it is balanced. So when a pivoted object like a seesaw, like a force arm of a crane, when it is balanced, then this principle is applied. So you have to first write that this principle, and remember this is the core topic of this chapter, this principle is applied when a pivoted object is in equilibrium balanced state. This principle is applied when a pivoted object is in equilibrium or balanced state if the algebraic sum of all the moments acting on an object taken on a common pivot is zero. The object is said to be in equilibrium. You have to copy this statement, inverted commas.
Done.
Now look at the diagram. There are two forces acting on the object and there are two separations from the pivot. Two separations from the pivot. When the object is in equilibrium,
Sir, could you repeat again?
Sorry for the disconnection. We are having internet issues here for even today and even yesterday. Please copy this screen. Let me know once you have copied it. Can you hear me?
Yes, sir. Done.
So let me know if you can once you are done copying it.
Done, sir. Done, sir.
So in equilibrium, the two moments are equal. When a pivoted object is in equilibrium, sum of clockwise moments is equal to sum of anti-clockwise movement. This is another statement. You can preferably use this one.
Sir, are you speaking?
sorry for inconvenience. Please look at the screen and copy it. If checks how much you have copied.
Done, sir.
Have you copied it?
Yes, done, sir.
Okay. If we translate it mathematically, it is F1 D1 is equal to F2 D2. And this is how we equate them. And it means that the resultant momentum is zero. Resultant moment is zero. You have to copy this.
Done, sir.
Now, this is a force equation, and this equation is used parallel to the law, equilibrium law. The total upward force is equal to total downward force. A very interesting rule. And it means that you can equate the forces also. And this is very helpful when you are solving MCQs on this topic. And total upward force is equal to total downward force. You have to copy this. So when a pivoted object is like this, the total upward force is equal to total downward force.
Done, sir.
Now, these are the examples. Our instrument, which is called chemical balance in our lab. This is the equilibrium balance. The crane lifting heavy objects has a long arm and it has two moments. Otherwise, this arm can fall. This is an equilibrium. This is another example of a crane. It is called harbor crane and it is also balanced it is also balanced by the concept of F1 D1. F1 D1 is equal to F2 D2. Now, verification of principle of moment. This is an old memory. Actually, it's a design question. And it shows that how you can justify the principle of equilibrium. You can take a meter rule and you can pivot it at 50 mark. Then you can put loads W1 and W2 on both sides. You can put loads like here and here. You can put the loads here. And if you try to move the loads forward and backward until the rod is horizontal, set square can be used to check the rod is balanced or not. Then you can calculate W1 D1. W1 D1 means moment. W2 D2 means another moment. So you can balance the rod and then you calculate W1 D1. If they are coming equal within a range, it means the principle is accurate. There is another concept used in our MCQs, that is a concept of counterweight. Counterweight is actually a movable weight. You can look at this screen. This is called a counterweight. You can move it forward and backward. You can find this on some shops where the weight is made very accurately and they move it forward or backward. Or if you have a chance to going to a doctor and the doctor has a weighing scale, he has these counterweights which the doctor moves forward and backward until the rod is horizontal. Similarly, the check post, they have a counterweight at the back. So if they release it, the barrier goes up. Elevators have a lift room, the old elevators. Now they are obsolete. The elevator whose door opens outside. So if the load, this is the load, if the load goes down, the lift passenger room goes up. This is another concept of counterweight. It is actually movable, so you can balance this heavy crane. This is a helicopter example. We have a big propeller and we have a backup propeller. The back propeller is actually providing a counterweight to balance the helicopter. Now you have to give the heading resultant moment.
Done.
Moments acting in the same, remember moment is a vector. So like all vectors, when the moments are in the same direction, they are added. And when they are in opposite direction, they are subtracted. You have to copy this.
Done.
M1 and M2, look at the circle. The wheel is moving in one direction and the moments are being added. Why the moments are being added? Because they both are clockwise moments. So moments in the same direction are added. You have to copy this screen.
Done.
Now you can look at this. Now the two moments are in opposite direction, m1, m2. The resultant moment is the difference. You have to subtract. Like moments are added, and unlike moments are subtracted. You have to copy this.
Done.
Each of the workers affects the drill with the same moment of force, equal to 300 Newton meters. The two workers act in cohesion. That is, the moment of the force of each of them individually results in the turning of the drill in the same direction. That is why their moments of forces add together. The resultant moment of the forces exerted by the workers on the drill is 600 Newton meters. In the case where the moment of one force results in a clockwise turn, while the moment of the other force results in an anti-clockwise turn, one of the forces is subtracted from the other. Each of the workers affects the drill with the same moment of force, equal to 300 Newton meters. The two workers act in cohesion. That is, the moment of the seesaw is affected by two forces, each of which is trying to turn it in the opposite direction. The moments of the forces are of equal magnitude. That is why the resultant moment of the forces exerted on the seesaw is 0. When the resultant moment of the forces exerted on the seesaw is not equal to 0, the seesaw starts to move. The seesaw is affected by two forces.
So now give the heading calculations.
Done.
The first, we are discussing some rules, calculation rules, and these rules are necessary to apply when we are doing calculations like this. So you have to copy these rules. I'm just coming, I have to say Asar Namaz. Please copy this and we are just continuing.
Sir, I can't hear you.
Let me know. Let me know if you can hear me, and have you copied this?
Yes, sir, I can hear you. I'm done.
Okay, have you copied this screen?
Yes, done. Sir, are you still there?
Yes. Have you copied it?
Yes, yes, sir, done.
Okay, good. So we are putting our first example, and no need to copy the example. No need to copy the example. You have to see the first question. Distance is always taken from the pivot. And the system is in equilibrium. We suppose that the system is in equilibrium. And we need to find the force. So you have to copy now this screen. I'm sorry, you have to solve this. No need to copy. Just solve this and let me know the answer. What answer you are getting?
Just a second, sir.
Hmm.
10.
Good. Look at this second example. Distance is always measured from the pivot. Again, no need to copy the question, and you have to solve it.
Is it 20?
No, it's coming 40. Are you taking the distance for 20 newtons 60 or not? Distance should always be taken from the pivot.
Yeah, okay, now I'm getting it.
Now, look at this screen, and you can copy a rough diagram for it if you want. Otherwise, you can tell me orally. No need to copy, leave it. Can you tell me that should I resolve 45 degree?
Oh, yeah, you have to resolve it.
Good. So I have resolved it. Now the concept is there that F1 D1 is equal to F2 D2. Clockwise moment is equal to anti-clockwise moment. So you have to solve this.
Will T be 10.6?
Look at the working. Have you checked it?
Yes, sir.
Okay, so we keep it up to here, and we will inshallah continue this in our next class. Thank you. Allah Hafiz.